We now know that the internet is a network of networks, but we've been glossing over what it means to be connected. In this episode, we'll take a deeper dive and review some of the main methods used to connect to an ISP. What we're talking about here is how you access the internet, what is commonly referred to as the last mile. Because data is coming from all around the world, and to get to your house or your phone, this is the last mile of its journey. Every home, every office building, every phone must have a connection. And that is why the last mile is so difficult, and why most ISPs started out as utility companies. They already had a connection to every building. There are broadly two categories for access: wired and wireless. Wired is a physical connection between two devices, and it comprises the backbone of all networks. A wired connection is the most reliable and fastest. However, that's not always very convenient. First, you need a cable for every device, and this gets very messy very fast. Second, if you're connected with a cable, you have to be in a very specific spot. You can't move around. Various wireless technologies started getting prominence in the late 1990s to give you that freedom to remain connected while moving around. Wireless connections are far more convenient. But what's important to note is that every wireless connection has a physical cable behind it. So let's discuss wired internet access. Developed in the 1980s but made popular in the 90s, dial-up is what really introduced the internet to the world. All homes were constructed with a connection to the telephone network already, and this telephone network could be reused to transmit data with something called a modem. Since the telephone network was designed to transmit sound or audio, it was the job of a modem to convert your data into sound and back again. This is where this wonderful sound comes from. That was the sound of a modem connecting your computer to the ISP. Those sounds are the sounds of digital data and code being converted to audio to transmit across the line. Once a connection to the ISP was successfully established, that audio conversion was still taking place in the background, you just didn't hear it. At the time, a huge drawback of using dial-up was not being able to use the telephone and your computer for internet at the same time, since both devices were using the same cable and technology. Bandwidth topped out at about 56 kilobits per second. Introduced in the mid-1990s, digital subscriber lines, or DSL, also used the same telephone network that dial-up did, however made use of a fully digital infrastructure, eliminating that messy conversion of data to sound and back again. Adoption of DSL marked the beginning of the era of always-on broadband internet access. Think larger and wider lanes for transmitting data. For residential usage, bandwidth typically ranged from 128 kilobits per second when first introduced to 52 megabits per second depending on cable quality and distance. There was another utility company with wires into every home, cable TV, and they wanted in on the game. In the late 1990s, the same coax cable used for cable TV could now be repurposed to transmit data. This allowed new players to enter the ISP market. Still widely used in 2023, bandwidth started out at around 2 megabits per second and now is commonly still available at over 100 megabits per second. The last wired internet access method is fiber. Fiber optic cable is literally a long piece of glass. Instead of using electricity, that data, however, is transmitted using light. These fiber optic cables are capable of spanning very large distances, on the order of 80 kilometers or about 50 miles. This makes fiber ideal for ISPs and other businesses with remote operations. Fiber for residential use, however, started gaining popularity when Google entered the ISP market in 2010, offering symmetrical upstream and downstream bandwidth of 1 gigabits per second, soon followed by other ISPs. When it comes to wireless, we are primarily talking about cellular wireless. Like dial-up access, cellular networks started supporting audio phone calls only. They get their name from the fact that the wireless signal comes from a tower, and that forms a cell. Each cell tower is connected to the ISP's wired network, usually with a fiber optic cable. Multiple towers, or multiple cells, can overlap slightly and provide coverage over a large area. Cellular access is typically going to support a long distance at a lower bandwidth when compared to a local Wi-Fi network. Cellular networks for voice calls grew very rapidly in the mid-1990s. and in just a few years started to expand beyond simply audio phone calls with the introduction of SMS texting, and soon thereafter with MMS, allowing users to send and receive pictures and audio files. The second generation, or 2G, of cellular networks made general data communication possible at up to 40 kilobits per second. Although first deployed in Japan in 2001, it took a few years before 3G was widely adopted. Popularity of 3G, or the third generation cellular networks in the US, coincided with the release of the iPhone 3G in 2008, which really brought cellular internet to the masses. 3G networks provided users with the bandwidth of up to 7 megabits per second. In 2009, the world saw the introduction of fourth generation cellular networks, most commonly referred to as 4G LTE. This marked a turning point for cellular access, as not only was there a proliferation of phones using it, but also with the rise of hotspots or mobile broadband for support for devices other than phones, like tablets, laptops, and even as a viable alternative for home internet. LTE supports up to 150 megabits per second, but is more commonly seen around 50. As of 2021, 4G technology constitutes 58% of the worldwide mobile communication market. 5G is the latest deployed standard as of 2023. It started rolling out in 2019 and supports bandwidths of over 10 gigabits per second, but with significant caveats. These higher bandwidths are achieved with more but smaller cells. Some of you may be looking around and thinking none of these apply to you, and that I might have missed something. Well, what we just went over are methods the ISP provides to you for access to their network. Now your home, school, or office might also have a local network which you will need to access, and that'll be in one of two ways. If you're plugged in with a cable that looks like this, you're using wired Ethernet. This is a very reliable, very high bandwidth access method that has been around for years, decades in fact. So why haven't ISPs just been using Ethernet all this time? Well, this type of connection only works over a surprisingly short distance, only 100 meters, or roughly the length of a football field. If you have no visible wires or cables around, then you're probably on Wi-Fi. These days, Wi-Fi can also be a very high bandwidth access method, and in some cases faster than wired Ethernet, but also a very short distance. Due to the incredible convenience it offers, Wi-Fi exploded in popularity in the early 2000s and has been getting faster and more reliable ever since. This is a different technology from cellular networks, but like a cell tower, the wireless signal comes from a base station or access point, which is connected by Ethernet cable to the local network. You just can't get away from wired connections. So how are you connecting to watch this video right now? Have you experienced all of the above access types? Leave a note in the comments below.